All right, let us do some exercises on distance, displacement, speed, velocity, average speed, and average velocity. So our first exercise here, a body moves along the curved part of a quarter circle. Calculate the ratio of distance and displacement. Okay, so here you should remember that distance is nothing but equal to the path length. All right, so the actual path traversed by the body, that length of the path, that is the distance, whereas displacement is just the length from the initial position to the final position. Got it? So here in this problem it says that a body is moving along the curved part of a quarter circle. Quarter circle means what? Let's say we have a circle out here. Let's say we have a circle somewhat like this. Then the curved path of a quarter circle, let me just draw a line from here. Let's say this is our center, the center of the circle, to this point, from here till here. Okay, so here it is a quarter circle, means that this part is not there. Okay, let me not do that. Instead, I will just rub it off a little bit. Let me make this rubber a little bit smaller. Okay, so this part is not there. Okay. All right, so that is a quarter circle, and this body, it is moving from point A to point B. Okay, and basically this is the radius, and let's call this center as O, and R here is the radius. Got it? So the body is going from point A and it's going to point B in that direction. Okay, so you have to find the displacement. What will be the displacement? Displacement is just the initial position to the final position, this length out here, this one. Just take a line directly joined from the initial position to the final position. Let's call this delta x. Delta x, that is the displacement. And what is the distance? Distance is this length. That means this arc, let's call this distance as s. Okay, so here, how do we find the displacement? This is a right angle triangle because it's just quarter, isn't it? So if it is a right angle triangle, is very simple. Okay, it's very simple. So here you have the the displacement will be just, this is we can use Pythagoras theorem here. So this square, it will be just this square plus this square under a root. So you have r square plus r square under a root. So you have a root 2 r. R comes outside of the root. Okay, whereas the distance here is this part. So this part, isn't it 1/4 of the perimeter of the circle? So that and the perimeter is 2 pi r divided by 4. So you have pi r by 2. So therefore the ratio of distance to displacement, that means s by delta x, so you get it to be pi r by 2 into 1 by root 2r. So this r and this r will go, and pi here is 22 by 7, 22 by 7, 1 by 2 root 2. So basically this will be 11. So you have 11 by 7 root 2 answer. So that is our first problem. Let us go to the second problem. Okay, so in this second problem we have a man walks for some time t with velocity v due east, meaning he is going towards the east. Then he walks for the same time t with the same velocity v due north. What is the average velocity of the man? And you remember the formula, average velocity is total displacement by time interval. So here let us draw the diagram first of all. Okay, so here from this point the man is going due east. So let's say this man is going this way. Okay, and from here he is going due north. All right, so the man is going this way with velocity v. Okay, and from here he is going with the same velocity v due north. And because he is traveling with the same velocity and same time, so the distance from this point to this point is equal to the distance from that point to that point. So let's call this distance as this point as O, this is A, and this is B. So let's take this distance to be x from this point to this point. That is x, and similarly from here till here, that will be same time x, same distance x. So this is x, and that is also x. So what will be the displacement of the man? The displacement is just this line connecting. Okay, let me use a different color here. This is the displacement. All we need to do is to find this length of the line OB. Got it? Okay, so displacement, let's call this delta x. All right, so delta x will be what? This is delta x. So delta x will be, again, this is a right angled triangle. We can use Pythagoras theorem. So this will be x square plus x square under root. Yes, so this will be 2x square. So that will be root 2. X goes outside. And what is the total time or the time interval? Time interval delta t. This will be what? This will be how long does he go from here till here? He's taking time t, right? Time t. From A to B also he's taking time t. So what is the total time? Total time will be 2t, right? And the time interval will be 2t minus 0. Okay, so this will be 2t. So therefore average velocity here is delta x by delta t. Okay, and delta x here is root 2 x. This is 2t. What is x by t, by the way? X by t is distance by time, that is speed. Yes, distance by time, that is speed. Okay, so you have v, or this displacement by time, that is velocity. So that is the answer. Okay, let's go to the third problem. So in this third problem, we have a car runs at constant speed on a circular track of radius 10 meter, taking 6.28 seconds on each lap. So that means it is taken in going one round, okay, one complete round or one complete circle. What is the time it takes? 6.28 seconds, right? So we have to find the average speed and average velocity of the car. Okay, so how do we do this? Again, it's very simple here. Let's first write the radius of the circle here. This is 10 meter, and time for each lap, this is 6.28 seconds. Okay, so even though the car is going around many times, what we can do is we can only find the average speed for one round. Got it? We can only find the speed for one round, okay, because it is going with a constant speed. So the average will be equal to the speed of one round itself. And similarly for the velocity. So we use this formula. Average speed is nothing but total distance by total time. Total distance by total time. And in one round, what is the distance it covers? Let me have a circle out here. Say this body is starting from point A. It is going like this and it reaches point A. So what is the total distance it covers? Is it not equal to the circumference of the circle? And the circumference here is 2 pi r. Okay, and what time does it take to cover one circumference? It takes this time, 6.28, right? So here 2 pi, you can write this as 3.14, into r here is 10 by 6.28. Now 3.14 and 6.28 you can cancel, this goes 2 and this will go, so you have 10 meter per second. That is the average speed. What about the average velocity? Average velocity is delta x by delta t. Delta x by delta t. What is delta x? Delta x is the displacement. If the body is going from A coming back to A, what is the displacement? See, it is displacement by definition is the distance from the initial position to the final position, right? So here the body is going from A, going back to A. Its initial position is A, its final position is A. So what is the distance between? What is the length from A to A? That will be 0. Yes or no? So its displacement is 0. And the time interval here, let's call it t. So this will be 0 meter per second. Okay. Let's go to the next problem. A body covers 1/3 of the distance with a velocity v1, the second 1/3 of the distance with a velocity v2, and the last 1/3 of the distance with a velocity v3. Find the average velocity. So if you have such a problem, the best way to do is to draw this line. This is the starting point and that's the ending point. Okay, so let's say the starting point here is A, then this will be B, this will be C, and that will be D. Okay, so the length here is let's let the total length be x, means from here till here, that is x, from here till here, so from here till here, that is x. From here till here, it is 1/3 of x, so that will be x by 3, x by 3. Then from here till here, that is also another 1/3 of x, so that is x by 3. From here till here, that is the last 1/3 of x, x by 3. So it is traveling along in this AB with velocity v1, BC with velocity v2, and CD with velocity v3. Got it? So here they ask you to find the average velocity. And average velocity is nothing but the displacement by time interval. Okay, so how do we find the time interval here? Displacement is just the initial position to the final position, right? So that displacement is nothing but x. So here displacement we represent this by delta x, that is x. Time interval delta t. Delta t is the sum of the times going from A to B, B to C, C to D. So this will be t1 plus t2 plus t3. Okay, and what is t1? T1 here is, we know that distance is equal to velocity into time. So therefore time will be distance by velocity, right? So what is t1? T1 here will be x1 by v1. T2 will be x2 by v2, and this will be x3 by v3. Okay, but what is x1 here? X1 here is x by 3. X1 means the distance from A to B, that is x by 3, and v1 is, let's call it v1 only. Similarly, x2 here is the distance from B to C, that is x by 3, x by 3 v2, and x3 here is the distance from C to D, which is x by 3 v3. Got it? So what will be the average velocity? Therefore average velocity, this is displacement by time interval. Displacement here is x and time interval is x by 3 v1 plus x by 3 v2 plus x by 3 v3. Okay, so we can do a little bit of calculation out here. So again, what will be the LCM down here? LCM here will be just the product of all these denominators. So it'll be not a product. 3 is common out here. So the LCM is 3 v1, v2, v3. Then this divided by 3 v1, you get v2, v3x. Yes or no? X will be outside. So you have v2, v3. This divided by 3v2. So 3 and v2 will be gone. You have v1 and v3. v1, v3 plus this divide by 3v3. 3 and v3 will be gone. You have v1 and v2. v1, v2. Close the bracket. Okay, so this x and this x will go. And this term here will go up. So you have 3 v1, v2, v3 whole thing divided by v2, v3 plus v1, v3 plus v1, v2. That is our answer. A particle moves in the east direction with 15 meters per second for 2 seconds, then northwards with 5 meters per second for 8 seconds. Find the average speed. So since this is the average speed, we don't need to draw the diagram. All right, so here the first velocity here v1 is 15 meters per second and the time t1 here is 2 seconds. Then the second velocity here v2 is 5 meters per second and the second time here is 8 seconds. So therefore what will be the total distance? Total distance is x1 plus x2. Okay, but we know that this distance is speed into time, right? So x1 will be v1 t1 and x2 will be v2 t2. Okay, and the total time simply will be t1 plus t2. All right, so why do we, you see, because here x1 we don't know, so we have to write x1 in terms of v1 and t1. So average speed is total distance, which is okay, let me write down the formula. Total distance by total time. Okay, so this will be v1 t1 plus v2 t2 divided by t1 plus t2. t1 plus t2. So here what is v1? v1 here is 15. 15 into 2 plus 5 into 8 divided by total time is 2 plus 8. Got it? So if you do this calculation, you will get 7 meters per second. So I guess that is enough. 5 problems is enough for you. Okay, so I want you to practice these problems nicely. Thank you.